Okay, now that we're remaining in the world of seasonality, we're going to be using these factors that we've generated here, but we're going to go from the last value, or what we call naive modeling, to let's get a little bit more sophisticated here with the averaging forecast method. Okay, so that means for any period, we're going to use all previous readings. The average of all previous readings will be our forecast for the upcoming period. Okay. So when we take a look at this, it looks like the same sheet almost, but what remains the same is we have the seasonally adjusted values. Okay, so here's our actual values. These are the readings. Okay, and what we did was had again to review what the seasonality factor is. It takes into consideration that each quarter will have its own seasonality factor, and what we did was we took the average of all first quarter readings and compared that to the overall average. And we found out that the first quarter on average is about 0.93 of the overall average. It's suppressed. Okay, so we have a suppressed, quarter one is suppressed regarding the average. It's lower than the average. It's 0.93 of the average. Quarter two is 0.9. The average of all Q2s is 0.9. The average of all 0.3s is 0.99, which is virtually 1. Okay, so it's 0.3, or rather 3/4 here, it is pretty much represents the overall average. Okay, so quarter four average, the factor is higher because these two numbers are lower. The first two numbers are lower than 1, and then we need something to balance it out. We need something to compensate for these suppressed, and this is amplified. Okay, so Q4 is amplified from the average. It's greater than, magnified. Okay, so on average, Q4 is 18% higher than the overall average, 1.18 to the 0.18 there. Okay, all right. So that's how we interpret those things. Okay, what we did is we took these numbers, and to normalize them for each quarter, we use its seasonality factor, divide by that. So we need to, we're amping it up a little bit. Okay, so when we divide by it, in this case, we get 7,322. Okay, so these are seasonally adjusted values, and if you go out to many reports put out daily in all kinds of financial instruments, much less other kinds of publications and whatnot, they talk about these numbers are seasonally adjusted. Okay, so it makes a more level playing ground to understand the numbers, is that there is a seasonality. We're trying to, so to speak, compensate or remove it here. Okay, and in the average, so the average that we have here, seasonally adjusted forecast for Q2, the average of just one data point is 7,322. So that looks like it's the last value. But then let's go down to here, the third quarter of the first year, it's going to be the average of these two numbers. Okay, we're using all previous numbers in this average. Okay, so let's go in there and do it. Okay, and then once we get the seasonally adjusted forecast, we need to go bring the round trip back home again, because where we compensated for the seasonality here, we have to do the opposite on the way out. We have to actually multiply it out by 0.93 here. All our forecasts have to use the appropriate seasonality factors, and then we'll look at the error. Okay, so a little bit of a flash forward on this. We could see, if we're only worried, if we're comparing one mode to another, the mean absolute deviation is actually higher here using the average than when you just use the last value. Previously, it was 240 something, I think. All right, so that's what we have our eye on, is we're trying to come up with the best process here, and we're numerically or quantitatively calculating that. We're seeing just how much the error is. So let's go through, back over to our spreadsheet, and what we can do is, let's see, so we have the forecast. So this forecast here, I put in a note that this is the 1.25 for quarter four. That was the original one that we talked about. Then we introduced seasonality. Okay, and what we did was, this is all the information for the last value method, because here's 7322, 71833. Okay, so what we can do is we can hide all this. All right, now we're going to run this. We're going to save it by just hiding it, put it out of the way here. and I'll probably have to move these over a little bit. All right, give myself a little room as I'm progressing here. Okay, so the forecast, the seasonal adjustments here. Okay, so we now need to put, what do they call? I'm going to use their heading here. Their heading is seasonally adjusted. Seasonally adjusted. Just make sure I use what they use. Okay. And what we could say here for seasonally adjusted is we're using the average, just to remind us what method we're using here. I'll put in averaging. It's full averaging. Okay, so the second period, the previous average is just the only number that we have there. Okay, so quarter two is going to be the average of 7322 with it just itself, so it's 7322. So now we need to do this forecast is going to be equal to average of those two numbers. You have to type this in each time. Okay, so now we need to do all the average of three numbers. Okay, you can speed forward on this in the video viewer that you're using. Okay, so let's just make sure the numbers are right. If we end up with about 7530 at the end, go back to the book where they have 7530. Okay, so this is the average of all previous readings that we have, but we're working in the realm of the seasonally adjusted forecast. Okay, so now we need to denormalize them. Okay, if you will. So now we have to take each of these numbers and multiply it by its seasonality factor. Okay, so you can see, so G7, if we look down here, G7 is going to be the seasonality factor K10, cell K10, okay, times F7. Okay, so remember, we're predicting for the second period, so we have to use the second quarter multiplier there. Just remember to do that. So what was the title they gave that? The actual forecast. Oh, okay, that's what they want to call it? Sure. Actual, it's a little bit confusing, but okay. Actual forecast. So we have to just take this number and multiply it by the second, be careful here, the second seasonality factor. Okay. All right. And I'm going to knock off the decimal places on that. And we can go to 2, and we can go to 3. Yeah, 3 to 4. Okay, we're okay dragging those down, but then we still have to start over again. It's going to be equal to quarter 1 times the quarter 1 seasonality factor. Okay. And once again, let me knock the decimal places off that. And so that's quarter 1, 2, 3, 4. Then we have to start over again. It's equal to that times quarter 1. 4. And then this is like our one true forecast because we don't have the data for it. And that's on a 1. Okay, so you have to be careful you pick up the right ones. Let's check to see that if I was careful enough. And let's go back here, and we have, just to do a spot check on it, 7003. Let's just check on, just a spot check. Let's see, we have year 2, quarter 4 is 870 something. Yes, right there. Okay, so that's year 2. I'm just spot checking to make sure my numbers are correct there. So there's our actual forecast. Okay, so now what do we do? Well, we can go back with our data and we can look at the errors now. So now we're going to look at the absolute error, because we need the absolute error for the MAD, right? Because it's the mean absolute deviation. Okay, so it's going to be the absolute of the actual minus the forecast. I think that's what they've got there. There's 124, 611 will be the next one. Let's do this. We can only go down here because we don't have the actual. And our last number is 834. Okay, so just to make sure that we're keeping up. All right. So now we're going to do the MAD. Remember, we're going to be after the MAD here. Okay, so we'll just do one at a time. I am just going to do a little bit of formatting here so it's a little bit easier on the eyes. And this is our error. I'll put in here absolute error. Okay. All right. Or error.absolute, either way you want to do that, but it's the error, and then the subcategory is it's the absolute value of those. Okay, so the MAD is the mean absolute deviation, so it's just going to be equal to the average of these. Okay, so they ended up with 400. Okay, we did fine. Okay, so now let's calculate on the mean square error. Okay, so now we need the squares. Okay, so I forget what I called them before, but the error squared. Squared. Okay, I'll use some nomenclature like that. I will center things up here so it's easier on the eyes. Okay, so we need all those is equal to the errors. What's the errors? Squared. Let's get rid of all those decimal places. And just drag that down. So those are the errors that we have. All right, don't really like that way. I think I'm going to have to push those to the right. There we go. That makes them easier, those numbers easier to read. Okay, so now the mean square error, what is that? That's just going to be equal to the average of the squares, 242,876. Okay, so we end up with what they have. Okay, so let's take a look. And now the discussion is, how did we do with the MAD? Multiplying all the seasonality adjusted forecasts in column F. We come through here. All right, so we came up with a MAD of 400, considerably larger than 295. Okay, so we're trying to develop a sense of what these MAD values can and should be. And they actually put a, not a normative, but a subjective phraseology around it, because they call it considerably larger than 295. Okay, so they consider, let's round 295 to 300. You know, it's 33% greater than the last value forecasting method. Okay, and they also found that the forecasting errors given in cell K26 is 242,876. So we're using two error calculations, both of which grew when we tried to use the averaging. Okay. So what happens when you average is you start desensitizing. Average will stop fluctuating very much after a bunch of readings because think about it. Every number that you get is probably going to be some area close to a mean. Okay. And the number, so when you use a pure average, you start having so many previous data involved in the calculation that the errors in your forecasting will never fluctuate anymore. It's so based in long-term history. And that's why we're going to move to the moving average forecast gives us more of a recent history than all history. Okay. So this one should probably run very closely to what we just did. Okay. So I'm going to come back here and what do we need here? Adjustments. Okay. So this column here, I'll paint it with, oh, why not? Let's go, well, I use orange. It's not quite worthy of the yellow, the golden yellow, but orange here, this is actually the forecasts of methodology. So these are the methodologies, all right, and that we used. Okay, so this was the complete running history of all points that we already used, and then we take it through a couple steps. We actually compensate with the seasonality factor here, and then we look at the errors and do the calculations. Okay, so I can hide these. We're gonna have one really long spreadsheet here, but it's nice. We just start tucking these away. Now we're going to go back and we're going to use the 4 periods. Let me hide these. Okay, so now what they call for, Lydia wants to just use the running average of the last 4 periods. So with these seasonal adjustments here, I can hide this one. That's a previous method, Control Z. Before they do that, I will paint that orange. So all the orange headings indicate that that's some technique. What technique is indicated in that column? So that's just hanging out there. I haven't hidden it yet, so let me hide that. Okay, so here's our base information here. Probably I need to move this one more time. Control X. I'm going to move it out a few. No, not that far. Maybe that far. There we go. Okay, so now we're going to use 4 period moving average. So that means here, those 4 will be used to predict the first quarter of the second year. So this is the first time we need to collect 4 quarters worth of data before we can go do this moving average. Okay, so let's use, actually this is going to go a little bit quicker because I can grab the 4 previous, right? And then I can just drag that down. Boom. Okay, so this is moving average. I'll just push that down so it's more readable. And that column I can center up. That centers up quite nicely. Okay, so let's see how we did. Let's go see how their table looks. Did we get those right? Okay, quarter time, seasonally adjusted. Okay, 7036 down to 7826. Okay, so spot checking the numbers. We just ran a 4-month or 4-quarter moving average here. Okay, so now what we need to do is just follow through what we've done before, what they call the actual forecast and the error. Okay, so there's the actual and the error dot absolute. Okay, so what's the forecast error? Well, we have to start here. The first place that we can do it is going to be equal to actual minus forecast. Nope, I'm sorry, I got too far out there. Actual forecast. This has to be compensated with the seasonality factor here. So we're on Q1. Okay, so we're going to say that it's going to be equal to that times seasonality factor. And I can grab, we're going Q1 through Q4. That's fine. See, as I drag that down, it's auto-incrementing the reference over here. That's what I'm talking about. It's auto-incrementing down to this point, but then we have to start over again. and it's going to be equal to this. So you have to start back at the top of the list again. Get that. Just take care of that one. Clean it up. Get rid of the decimal places. Where's Q4? Right there. And then finally, we have to get back to the top of the table here. There we go. Okay, so our one true prediction that we're still waiting on, our 13th quarter here, let's see what we have to do here. Get rid of some of these decimal places. Is 72.29. Let's just double check, make sure everything looks good. 72.29. Okay, so yes, I just did some quick spot checking here to make sure the actual forecast. Actually, I can do that whole thing. Again, just a little bit of housekeeping on that. So the error, the absolute error for MAD is going to be equal to the actual that we got minus our forecast, 713. Okay, we can bring that right down. MAD we can do fairly easily, so it's a mean absolute deviation. Tuck it right there. It's going to be the average. I'm going to have to go back and fix this. The average of these. Okay. And I didn't do the absolute on these, so let me fix that again. So it's going to be absolute of the difference. Nothing too bad there. Just drag it down. Okay. I just forgot to do the absolute on that. Okay. So the mean absolute deviation is 437. It went up. Remember, it's worse. It's worse than the full average. It's now 437. Okay. So now let's do our error squared. So that's going to be equal to that. Really, we're trying to sell decimal places today. Look at that. 8 decimal places. Great. Okay, and I'll just center that up. Center that up. Oh, this is the one where I probably want to move it to the right anyway. There we go. That looks better. And then we can figure out what the average of those is, the mean square error. Okay, we'll put that is equal to the average of these squares. Now remember, we're doing the squares because this amplifies. When we square an error, if it's a big error, it gets amplified. Okay, because the squaring function, the larger the number, it has a large effect, a square on it. So notice that our mean square error is pretty high. I think that went up. I forget what the other ones were, but they were. I think that went up also. Let's go take a look at this. Make sure we get the right numbers here. 230. Yeah. Okay. So 230 and 437. Okay. All right. So okay, so they don't give too much commentary on that one. So basically, when you use the moving average, what was the difference between 437 and 238 with the previous was... So we went up a little bit by using the 4-period moving average. We went up from 400 to 437, and actually the mean square error came down a little bit, 242 to I think 238. I think I said here. Okay. All right, so there hasn't really changed. It's a little worse in general. Yeah, the mean square error was 238, so it went down a little bit. But that's a little bit worse. What would you say? It's about 10% worse, right? Because the previous reading was 400-ish, and we went up about by 40. So our MAD went up by 10%. Okay, so let's do the exponential smoothing. So when we get to the exponential smoothing forecast method, there's a little switch of thinking. All right, they're going to simplify things here. Okay, I'm going to go over what they're talking about a little. All right, so they say our forecast is going to be equal to some alpha that we decide upon, some number between 0 and 0.999 or 1. Okay, And look at what this says, is the forecast for the next period is going to be the last read that we had. We're going to multiply that by this alpha. And then we're going to add 1 minus alpha. So you think about it is we're sharing one factor among two variables, okay, or on two values. We see alpha times the last value plus 1 minus alpha, that's what we call the complement, okay, of the last forecast. Okay, now the reason that they do this is, if you think about it, what I'm going to go over here and draw for a second. I think I still have this up on my screen. Okay, so let me draw a line across here. Okay, so what they were saying is, here's your forecast value. Okay, what you'd normally do with exponential is, let's say we're going to use 3 terms. Okay, so let's say we're going to use 3 terms, in other words, 3 previous periods worth of data. And what we talked about exponential, it says that we would multiply the previous with a heavy weight. It's heavily weighted. This is t minus 1 period. Okay, and then we diminish the factor on t minus 2. And then we include a little bit of t minus 3. We're emphasizing the most recent period, diminishing it to the, actually quite, it can be quite significantly, 2 periods ago, and quite diminished for 3 periods ago. And that's what our forecast would be, right? So that would look something like 0.7 times t minus 1, whatever the value of t minus 1, okay, plus 0.2 times the t minus 2 plus 0.1 t minus 3. See, these are our 3 periods here. And we would weight it with 0.7 of the weight would be on the previous, 0.2 of the weight would be on 2 previous, and 0.1. So how that diminishes, but they all add up to 1, right? So that's the weighted average. Excuse me. So what they do to simplify the math, they're doing to make a great leap here. It's just something to remember and memorize basically, and use and understand, is instead of, and you could go ahead and do this. You could use exponential smoothing for this. That's fine. But what they find out is that we can use the last value here by alpha. We're just going to multiply it by alpha times t is the t minus 1 factor. Okay, so whatever the previous value was at t minus 1, we're going to multiply that by alpha, right? But then we're going to take, all we're going to do, the math works out so that you do 1 minus alpha times this. This is going to put in here, this is the reading of t minus 1, and this is going to be the forecast for t minus 1. What did we forecast in that period? So we really condense everything. We really only have to look back at one period. We're going to use its forecast, and we're going to use its reading, if you will. Okay, so that's what they're talking about here. Okay. Okay, so if you're thinking about this, one of the issues is we're going to start really with predicting. We're going to have one reading for the first quarter, and then we're going to be able to start predicting the second quarter. Okay, if we do that, okay, so let me adjust my sheets here. I am going to hide all those. Okay, so we have that technique under our belt, so I am going to hide those. All right, so we need to make a prediction here. So we're going to be using exponential smoothing. Okay, exponential smoothing here. If we go to predict 2, we need the previous value. This could be alpha times the previous value plus 1 minus alpha times the previous forecast. Well, we don't have a forecast here. Okay, so let's take a look at what is the average of these numbers. Actually, if we go to text, I think they give it to us. All right. So we see we don't have those forward-looking numbers, and what they do in here is they tell you that, okay, so we come through here. They give you a little bit of an example. If you used alpha is equal to 0.25, and the previous reading was 224, plus 1 minus alpha is 0.75, okay, times some forecast, the previous forecast. That's just give you a really quick check-in to make sure you're following what they're talking about, right? But what happens here, you have to read through how you pick alpha, and alpha means everything. You have to be really careful about how you pick alpha. It comes through experience and relating to the numbers and stuff. But when making the first forecast, there is no last forecast. So you have to make an educated guess. And if you go and read through here, that's what they do. They say the initial estimate is 7,500. All right. Okay, so we'll plug that in. Come back over to our sheet. Okay. And they tell us to use 7,500 for the first forecast. Okay, so for the second quarter, right, this is arbitrary because we had to fill the pipeline. We don't have any previous forecast here, but we do have the current volume here. So the forecast for this, we would have said, was 7,500. Let me just move these. All right, so 7,500 exponentials. Okay, so now what do we need to do? I'm going to create a box here, down here, and we're going to say alpha. Okay, so what's alpha? And I believe they tell us to use 0.5 in this one. Yeah, so 0.5, just arbitrarily, there's not much to understand on that. It's kind of like, let's go with it right now. So our alpha for tracking through here, they decided was going to be 0.5. So what do we need to do? We need to, now this is going to be somewhat of a formula here, right? So we have to do, there's going to be two terms in here. Okay, so we need alpha times the previous value reading plus 1 minus alpha times the previous forecast, the one right above us, right there. Okay, and with that, let me just trim that in a little bit. Okay, there we go. Okay, I need to make an adjustment on this one because what we need to use is the seasonally adjusted. Okay, let me just fix that. There we go. I fixed the wrong part of this. Let's fix this again. So this is going to be, our alpha is 8018 times, and this is where I need to fix it, right here. Seasonally adjusted. There we go. Actually just changed it in the wrong area. There we go. So once again, and let me just go over that quickly. Okay, so the second term, the second period that we have, okay, so 8018, let's name this alpha, see if it will pick it up. Sometimes there's a little bit of a lag from the time that you name a cell to when it starts getting picked up. I'm not really sure why that is, but let's see what we got here. Okay. Save this file, Control Save. That might kick it. For some reason, there's something that has to instigate Excel to start using the cell references. I'm not quite sure what that can be, because what I'm trying to show here is that the word alpha should show up where it says 8018. Okay, so alpha times J4 is our seasonally adjusted, plus 1 minus alpha times the previous forecast. Okay, so again, I'll make that orange. That's an orange, okay, because that's a forecasting method. All right, so let's see, 8018. And what I'm going to do is we need to lock that down. So I'm hitting it with an F4 because I want to pull this down. All right, so I just put the dollar signs in there. And then we should be able to bring that straight down to here. Okay, down to the 13th month even. Okay, let me center that up. That it's a little bit more presentable. Exponential smoothing. Okay, so they call it the actual forecast. Is we have to bring it back. The round trip on this is we actually have to take each of our forecasts and multiply it by its appropriate factor here. Okay, so remember, we're able to seed or feed the system. They told us to use some kind of outside knowledge to do that first prediction here. So in this case, we're able to actually have a forecast for the first term. Okay, so I'm going to be able to drop that down 4 cells. We get rid of the decimal places there. Okay, but then we have to start over again. It's going to be equal to this times Q1. And let's get rid of those. 3. Okay. Before I go too farther, I just want to double check, just make sure we're on the right track here with the book. Okay, so let's take a look at this. Just make sure 6975, yeah, looks good. And down at the Q4 of year 2, so here's Q4 of year 2, 9136. Okay, just wanted to make sure that everything was tracking well. Is equal to that times our seasonality factor. Through 4 quarters, and then we have to recycle back to the top again. Okay, I'll put this down here. Let's give that a color. Okay, so there we have the actual forecast, and then we can go through our MAD. Let's see what happens here. Okay, so this is the error, absolute value of the error is equal to seasonally adjusted. We need absolute that. Go. Okay, so our MAD came down. It's coming down a little bit. It is 324, and we need the error squared. Okay, so we have a MAD 324 and an MSE of 157 or 158,000. Okay, let's go take a look. How did we do here? 324, 158,000. Okay, just want to make sure that looked right. Okay, so that's what we do. Now you've got the pattern going. I think I'll let that suffice. And each time we go through this, you can use these nice sheets that we have here, these nice forms that we have. We've actually built ourselves. Okay, so I actually have this all on one sheet. If I were to unhide everything that I've hidden so far, I think everything hidden is in here. Okay, I have the record of all that. Okay, so if I unhide, right, this is the history of what I just did in these two videos. Okay, I'm going to hit Control Z because I want to hide those again. Right, so I just undid the hide or the unhide. I'm going to hit it again, and so now we've gotten to the exponential. All right, so I'll leave it at that. I'm going to post these. I want to get these posted so you can get working on your final report. And it basically means walking through these with a different set of data. Okay, very good. And contact me if you have any questions.